We're going to be talking about limits involving infinity. And a fundamental limit on which many others depend on is the one stated here. And that is the limit as x approaches infinity of 1 over x to the nth equals 0, where n is any positive power. Now, let's take a look at the example to the right on that table. We're assuming here that n is 1. So basically we're looking at the function f of x equals 1 over x. Well, when x is 100, we have 1/100th. Okay? When x is 1,000, we have 1/1000th. So let's assume that we're dealing with a dollar here. 1/100th. Well, we have 1 cent. Okay? Well, let's say we have x being a million. Well, then we have 1/1,000,000th of a dollar. Notice that as x gets large, what happens? Well, our function seems to be approaching what value? Well, it seems to be approaching 0. So this is proof by example of the fact that the limit as x approaches infinity of 1 over x to the nth equals 0. Because think about it. X gets increasingly big, and we're basically taking, some function, dividing by infinity. Well, we're cutting it into really small pieces, so we're approaching 0. So let's take a look at the example that they provide for us. And they say the limit as x approaches infinity of 3x squared over x squared plus 5. Well, why can't we just plug in infinity? Let's try it. Let's see what we get. 3 times infinity squared over infinity squared plus 5. Okay, well, these two numbers on the top and the bottom are infinity, so why can't we just say we have infinity over infinity and state our answer is equal to 1? Just as in, suppose 5 divided by 5 was 1. We tend to line these things out and call that 1. Well, the problem with this is that the logic is wrong. We actually can't do this. This is actually, in math, illegal. So we can't really do this. This is not possible. So we're going to take a look at this example, and we're going to actually perform this limit appropriately. So let's go ahead and take a look here. So what we're going to do is we're going to take this limit and we're going to multiply it by a certain factor, and that factor is actually going to be associated with the largest power in this expression. So let's see here. We have 3x squared and x squared. Well, it seems that the largest power here is going to be x squared. So let's go ahead and take a look and see what we write. So we're going to actually take this limit. We're going to have the limit as x approaches infinity of the same function, 3x squared over x squared plus 5. And I'm going to multiply the numerator and the denominator by 1 over x squared. Now you may ask, well, where did you get this from? Well, it deals largely in part with the 3x squared here and the x squared here being the largest power in this expression. So, okay, let's continue. Well, when we do that, when we distribute this in, okay, we distribute it to all terms there, we're going to get the limit as x approaches infinity of 3x squared divided by x squared over x squared divided by x squared plus 5 over x squared. Okay, now let's go ahead and see if we can't reduce some of these fractions that we've produced. Well, we have x squared divided by x squared, and that actually just gives us a factor of 1. And then in the new denominator, rather, we have x squared over x squared, and that gives us a factor of 1 as well. And let's see here, this part right here. Well, let's recall from our previous page, and let's go ahead and take a look at that right now. We stated here the following, and that is the limit as x approaches infinity of 1 over x to the nth equals 0. So let's take a look at our problem once more. Okay, what happens in this case is that this actually turns into a 0 because we're looking at the previous theorem that we had pointed out. So let's go ahead and take a look and see what we've got left. Okay, we end up having when we simplify this, the limit as x goes to infinity of 3 over 1 plus 5 over x squared, and again I said that this was 0, so essentially we can't plug in infinity here. We're left with the limit of a constant number, and the constant number happens to be 3 divided by 1 plus 0, which for all intents and purposes is just 3 over 1, which simplifies to 3. So the answer to this problem right here is 3. Now, let's go ahead and take a look at some more information. So, as a general rule in handling a problem such as the one we just saw, we will find the highest degree in both the numerator and denominator, okay, and we're going to multiply in the following fashion. Okay, so let's go ahead and take a look at another example, and then we'll finish up. Alright, we've got the limit as x approaches infinity of 7x squared minus 2x over 4x cubed minus x. So take a look, ask yourself, which is the biggest exponent? Well, in this case, it happens to be x cubed. So what we're going to do, I'm going to rewrite it here for you. The limit as x goes to infinity, 7x squared minus 2x on top, 4x cubed minus x, and I multiply by 1 over x cubed and 1 over x cubed. So that will greatly simplify the process. Again, of course, I distribute in, and I end up with the following. The limit, of course, x still goes to infinity. We haven't evaluated this, so we continue to write this. 7x squared over x cubed minus 2x over x cubed, and then in the denominator we have 4x cubed over x cubed. Let me fix that. There we go. And minus x over x cubed. Okay, now let's go ahead and simplify this just a little bit. So we have here the limit as x goes to infinity of 7 over x, because that's what happens when you reduce there, minus 2 over x squared over 4, because these x cubes line out, minus 1 over x squared. Well, let's think about this for a minute. We have several items that fit the condition where the limit as x goes to infinity of 1 over x to the nth equals 0. So the following items that I'm going to circle here for you, this one, and this one, basically all go to 0. So I'm really left with something that looks like this. 0 minus 0 over 4 minus 0. So I have 0 over 4, which in this case simplifies to just 0. So the limit in this example is simply 0. Quite a bit of a process here, but it's not too difficult once you break it up like that.
Made with Doodlecast Pro.